Okay, ready to start. So let's talk about a couple on these on 33. So in 33, we got this one, 2 to the x over 3. So what is our general form for a exponential function? We have a general form for all these functions. Many of you are saying it. That's good. A, b to the x. And then what is b? Okay, it's the growth factor for what compared to x? So which growth factor is it? What's that? So which growth? So we have all these different growth factors, right? The half unit, the 3 unit, the... Yeah, so b is the 1 unit growth factor, meaning 1 unit of what? So 1 unit of what? So let's call this y equals a times b to the, or a times b to the x. 1 unit of a. What does the 1 unit refer to? B is what we would multiply by every what? 1 unit of... Okay, we know we multiply b by the old output to get the new output, but why is it called the 1 unit growth factor? Because that corresponds to a change of 1 unit of... There's no time in this. You keep saying time. There's no time. What is it? 1 unit of what? X. So the 1 unit is referring to if you were to advance x by 1 unit... If you were to advance x by 1 unit, you would multiply the old output by b to get the new output. Does that make sense? So the 1 unit is referring to how much we change x and get the corresponding change in y by multiplying by b. Okay, so I want to make it look like this. I want to make this function look like this one here. So what would a be? So this is the same as 1 times what to the x? So what to the x is the same as 2 to the x over 3? 2 to the 1/3. Do you see? So now I've got it. So what is 2 to the 1/3? That's the 1. 2 to the 1/3 is the 1 unit growth factor. Meaning if I advanced x 1 unit, what will happen to y? If I advance x 1 unit, how will the new y compare to the old y? Multiplied by 2 to the 1, not doubled, multiplied by 2 to the 1/3.
So the 3 unit growth factor is that.
Okay, so that's our 1 unit growth factor. So how would I advance 3 units? So if x advances 3 units, what would we end up multiplying by? We'd end up multiplying by 2 and 1/3, what? 3 times, right? So just think of this as like old y times 2 and 1/3 times 2 and 1/3 times 2 and 1/3 would equal the new y, how many units later? 3 x units later. So that's the 3 unit growth factor, which is 2 to the, so it's 2 to the 1/3 cubed, which is 2. So what's happening every 3 units to this quantity? It's doubling every 3 units. So every 1 unit, it's being multiplied by 2 to the 1/3. So this is the 3 unit growth factor. Okay? What's the 1 unit percent change? 1 unit percent change. So if we get that from what? We get that from the 1 unit growth factor, right? So how are we going to get the 1 unit percent change from that? Yeah, solve that out. What is it? 1 point something?
259.
26?
Yeah.
So 2 to the 1/3 is just about 1.26, meaning the percent increase is 26% increase per unit. So this was part, this is the parts, the answers are all over the place here. So here is our part A, initial value is 1. The 1 unit growth factor is 2 and 1/3, that's B. So here's part A. Here's part B. This is part C, right? The 4 unit growth factor. We can easily get that from what? We want to know what would we multiply by if we advanced x 4 units. What would we multiply by?
2 to the 1/3 and 2.
Exactly, 2 to the 1/3 4 times. In other words, 2 to the 1/3 raised to the 4th. So that would be 2 to the 4/3 would be the 4 unit growth factor. Yeah, the unit, how many units, that's saying how many units you would advance on the x. And so then the factor is then what would you multiply the old y by to get the new y by for that advancement of x, that many units of x. What's the 1/5 unit growth factor?
We have 2 to the 1/3 raised to the 1/5.
Yeah, so you can always, everything in these problems really revolves around this. The 1 unit growth factor, like all percent change, all the other growth factors, get that 1 unit growth factor and then everything falls out from that. So what was this, the 1/5 unit? So start with the 1 unit growth factor and we take 1/5 of that, right? Like that. Is that right? No, we want the number that multiplied together 5 times gives us this. So what do we do instead? Raise it to the 1/5. So that's 2 to the 1/15 is the 1/5 growth factor. 1/5 unit growth factor. Let me do a decay. Should I do B or C? Yeah, let's do C. Okay, so let's skip to C. Questions about part A? So what I always do is I always try to get this x out here by itself because then whatever's in the parentheses is your 1 unit growth, whatever that unit is right there. That's the 1 unit growth factor for that variable. And then all the other ones can come off of that one. Okay, anybody have a question? Does it help? What did I say, part C? Part C. What's the function? 3 times, I'm sorry. To the 2x?
Mm-hmm.
So we'll do the same thing we did before. What's the initial value? Yeah, this is the same as multiplying by 1. So therefore, if we have our a, that's our a right there. Okay, so we want to write this in a times b to the just x form. And then we'll know that b is the 1 unit growth factor. So So if I just want to isolate an x out here, what will I have to put inside so we get the same result as that? So we want these to be equal. We want an x outside. So what will be in the parentheses to make it equal to this?
2.5 squared.
0.25 squared. Okay, what if, so, you know, you make a guess. What if you're not sure? What can you do? Just solve this. Solve what you guessed, and it ought to equal what we started with. Do they equal? You raise something squared and then take that whole thing and raise it to the x? Do you get this? 0.25 to the 2x. Yeah, if you take something to a power and then raise that whole expression to a power, you can just multiply exponents. So we're good. So what's the 1 unit growth factor? Is that what the first thing? So the initial value, again, is 1. So part 2 is the 1 unit growth factor. 0.25 squared. Yeah, thank you. 1 unit decay factor. What is that? 0.0625?
Yeah.
Okay, so what is our percent decrease? Yeah, so this is important. Percent decrease. So, can you find the 1 unit percent decrease from the decay factor? Remember, that's a little bit harder. What do? Start with 1 minus that. Because the decay factor represents, what does that represent? How much we lose? It's how much we keep. It's the fraction that we keep every unit. It's the fraction that we keep every unit. So if you want the percent change, you've got to first figure out the fraction that goes away, which is 0.9 what? 9375? So this is what, if we're only keeping this little fraction, that means each time this fraction's going away, which is every unit, this thing loses 93.75% of itself, and we keep 0.0625. Okay, 5 unit decay factor. That's number 4. Five-unit decay factor. How can we get it? Yeah, the 0. Or we could just go the 0.0625. Or that's the same as 0.25 squared. Either way. Yeah, so a 5-unit decay factor is going to be the 1 unit decay factor multiplied together 5 times. If we want to advance 5 units, we got to keep multiplying by the 1 unit 5 times. And that's what an exponent does. It says, how many times do we multiply by that number? It's really low, he said.
It's like 6 zeros and then to the 9. Or it's 9. 2
6 zeros?
So it's 9.5 times 10 to the negative 7.
1, 2, 3, 4, 5. Yep, they got it. Okay. So what is this very, very small number communicating, or what is it representing in this problem? What does that number mean?
The amount of whatever we're decaying after 5 units.
If 5 units of x go by, how does what we started with now compare to what we ended with? I hope you didn't want it, right? Whatever it was, whatever quantity it was. You don't want it because, or I hope you didn't want it because 5 units later, you got almost nothing left. Like virtually none left, okay? So this is what we're keeping of the original amount. 5 units later is gone. It's like, it's almost gone. This is like 0, right? This is like, we're talking about a very small fraction. to say the least. 1/3 unit decay factor. Start with the same thing. Start with the 1 unit, which is 0.0625. And raise to the 1/3. Tell me. 6.6? 6.7? Okay. What's the 1/3 unit percent change? What's the 1/3 unit percent change? She wants 33% decrease every 1 unit, or every 1/3 unit. That's right, because it'd be, this is how much we keep. We're keeping 2/3. Every 1/3 of a unit, you keep 2/3 of what you had. So you're losing 1/3 of what you had, or 1 minus 0.67, 0.33, 33% loss, or percent decrease every 1/3 unit. Questions on number 33? Does this help?
I got a different number for that.
Oh, what'd you get?
0.396.
This is 0.396?
Yeah.
Yeah, you spoke up just in time. Okay, so quickly, this was supposed to be 0.396. So now, figure out what the percent change is. Go. Figure out every 1/3 unit, what percent change does this have?
Do you keep getting that?
39.6%, right? No? What is it? It's basically 60%. So this is like about 0.4. We're keeping 4/10. So we're losing 6/10 or about 60%. Any other questions on number 33? So losing 60% every 1/3 unit of x. We good on 33? What was the other one? 35?
Yeah.
Okay, so these decay factors, are they multipliers on input or on output? Oh, that wasn't a resounding.
Output.
Yeah, they are multipliers on output. So if we were giving points on a graph like this, and we're trying to figure out a decay factor, we're going to focus on, what are we going to focus on?
Output.
Which is
Y.
y coordinates, right? So it's showing here that it's at 1, it's 367.5. 1, 3, 6, is that right?
Mm-hmm.
And then what's the next point?
4, 126.05.
Okay.
6, 61.766.
Is that all the information we're given?
Yes.
Perfect. Okay. So what should be, so in order to answer any question they could throw at us, what do we kind of want to start with finding?
The 1 unit
1 unit growth factor.
decay.
Or 1 unit decay factor, right. Okay. So is it the multiplier that gets us from here to here?
No.
What would that be?
3 unit.
So let's just call that B3. The B value for 3 units. How would we find B3? How would we find the number that if you multiplied by 367.5 would result in 126.05?
126.05 divided by.
Yeah, so yeah, in unison. You're just gonna, it's gonna be this fraction. And if you're not sure, just set it up. You would say 367.5 times B equals 126.05. B3. And then solving. So Should make sense. If you multiply this number by the 3-unit growth factor, you'll get the output 3 units later. We're jumping from 1 to 4. So what is that?
It's like 3.43.
3.43?
No, 0.343.
0.343 is the 3-unit. I think they asked for that, didn't they?
Yeah.
3-unit growth factor. Decay, right. Yeah, so growth factor is kind of a generic term for both. But yeah, you're right. We should say decay factor. It's a little clearer. Okay, so what about the 1-unit decay factor?
It's going to be a third as much as.
If you're not sure, it's the number that if we multiplied, sorry, this should be B's. So call it B sub 1. If we multiplied that number together 3 times, it would be the same as multiplying by 0.343 once. So it's a number that advances 1 unit. So 3 of those multiplied together will be the same as the number that advances us 3 units. So B1 cubed equals 0.343. Or the third root of 0.343. Tell me what it is.
It is 0.7.
0.7 exactly?
Yes.
Percent change, 1 unit percent change.
30%.
70%?
No.
7%?
No.
30% decrease.
So then it goes into the 0.6 unit decay factor.
So the 0.6 unit decay factor. Not my favorite question. But how would we do it?
You take the 1.
6/10. Take the 1 unit and
You put it to the power of 6.
put it to the power of 0.06. What is it?
0.81. Pretty close to that.
So interpret that. What does that number mean, 0.81? Tell the person next to you. What does the number 0.81 mean? Okay, who thinks they got a good answer? Someone over here who's got a good interpretation of the number 0.81. Don't be shy. Does that number give us or tell us 0.81? Tell me.
For every 0.6 unit that you lose 90%.
She said, so if x advances 0.6 units, then whatever quantity loses 19%. If you go 6/10 of a unit of x. Agree with that?
Yes.
Agree? She agrees? Yep. That's it, okay? So yeah, so if you advance x point or 6/10 of a unit, you're going to keep 81% or lose 19% of what you had before. So that's your multiplier. 0.81 is your multiplier on the output to get the new output 0.6 units later. Okay, so I want you to work on page number 2, on page 154. This is, everyone, this is easy. Review. Number 2 should take you 2 minutes at the most. Just A, B, and C. Part 2, number 2, A, B, and C.
gosh, it's education college. You are no place. Number 2. You guys just want to have to module 5.
You all done, Riley?
Okay. Me? Who are you talking to? Me? I haven't done anything. Are you kidding? Might be for my necklace. What do you mean that? That's for friendship. I don't know what the symbol means, but it says
Okay, so this thing compounding. So let's talk about what the word compound means. When you compound, it means you're going to calculate the amount of change, whether that's an addition or a reduction. But so for a money investment, it's going to be an addition of interest. You're going to compound how much that is, and then you're going to put it back in with the original amount. So then next time when you compound, how will the amount added compare?
It'd be 1.8%.
No, just in general. So what happened to our like base amount when we compound? The base amount increases. So if we take the same percent and add it in again, now what about the second increase compared to the first? Larger because it's the same percent of a greater value. The idea of compounding is that the interest not only builds on the base amount, but it's building on past increases of interest. Okay? So, what'd you get for annual growth factor? 1.08. Okay? How much will this thing be worth? Was it 18 years later? So, we've got 5,000. How do we find out how much it's worth 18 years later?
Times 1.08 to the 18th power.
Every year, we'd increase it by 8%, or in other words, every year we'd multiply it by 1.08. So 18 years later, how many times have we multiplied it by 1.08? Repeated multiplication is the name of the game, right? Repeated multiplication. That's what an exponent is expressing. It's expressing repeating the multiplication that many times. Okay? And cha-ching, how much? 90,000. Only 19,000?
Yeah.
90,000, sorry.
19.
019?
No. It's 19,000. Not 90, 19,000.
No.
It's definitely not enough for college. It's not even enough for 1 year.
What was the?
It's about 10 cents. Yeah.
Really? That's all?
Yeah.
Okay. Yeah, better put away more now, right? Better put away more now. Okay, so C is the function, is that right?
Yeah.
Yes. 5 times 1.08 to the p power.
This is is what you should have got. Okay, so this is the percent change is 8%. So is the monthly percent change is it 8% divided by 12? Or, in other words, 0.08 divided by 12. Is that the monthly percent change? It is not, okay? But the banks do it this way, okay? So this is good. This is contrary to what we've learned so far, but this is how, if we're going to compound monthly, this is how the banks do it. They take the annual rate and they just say, okay, if we're going to compound monthly instead of annually, we're going to take that 8% and we're going to just divide it by 12. And that's how much we'll have it increase every month. Okay, so what is the month from this then? What is the monthly growth factor? So that's the monthly growth factor, 0.0000. Okay. Is that the monthly growth factor?
No.
What's the monthly growth factor for a percent change of 0.08 over 12?
0.81.
Growth factor, guys. How do we get growth factor?
0.08 to the.
What's that? She wants to put a 1 at the beginning. This is like percent change, right? 0.66% change. So what's the monthly growth factor? 1 point, right? It's going to be 1 plus that. Okay? So, then what would the annual growth factor be for this? We are at 1 plus 0.00667. How would you find the annual growth factor corresponding to this monthly growth factor? What would you do? You would raise it to the 12th. Tell me what that is. 1 point. What happened? So annually, what was it? It was going up 8% every year. By taking that 8% and chopping it into 12, what is it really doing now every year? It's a little bit better. Do you see that? It's a little bit better this way. So it's to your advantage that they do this. They instead of doing what we did before, which is always the case. So with 8% annual growth, what is the true? If it's truly doing it this way, what is the monthly growth factor? What is the monthly growth factor? 1.08 to the 1/12. Find that. 1.0064. Okay? That corresponds to how much the money is going up every month if it goes up 8% a year. But what they do is they take the annual rate, 8%, and instead divide it into 12 pieces. And then that's how much it goes up per month. And so then that would be equivalent to it going up 1.083 per year. Okay? So before monthly was going up this much, but now monthly is going up this much. Before annually it was going up this much. Now its factor is this. Which would you rather have? Okay, so because we'd rather have this way, we need to learn this way. Even though it kind of contradicts what we've said so far. It's taking the percent change and just simply dividing it by 12. But that's how banks do it, and it's advantageous for us who are gaining interest. Okay, so take a look at page 155, number 4. You're just ready to start right at A. So 4A, based on what we just talked about. Yeah, 4% per year compounded monthly means this. Means you're going to take the annual rate and you're going to divide it by 12 to start. And that's your monthly rate.
Which is the one through 4 is the original amount plus the
So what was yours?
Yeah. So this right here would be See, 1.0033 to the 12.
Okay, so what you just did, questions on what you just did. So what is the monthly interest percent change, both as a decimal and as percent? So the way the banks do it would be 4% over 12 or 0.04 over 12, right? They break the rules, right? They break the rules, but it's to our advantage. So is this 1/3%?
0.0033.
Yeah.
Yes.
So 0.33% or so that's part A. Make sense? Determine the monthly growth factor. Which one are we going to use, the first or the second? Second, and the monthly growth factor is 1.00, right? If this is our percent change, we keep what we had before, and then we want the percent change right there. That's part B. Okay, part C. Annual growth factor. Raise it to the 12th. So 1.0033 raised to the 12th. Okay, so same exercise. So this number right here, this is called the APR, the annual percentage rate. Is it the return that you get on your money annually? Do you get a 4% return on your money? Do you get more or less? You get a better return if they do it this way. If they chop it up into, say, 12 pieces, and then you recalculate. So let's find, what is anyone find the 1 year growth factor as a 1 point?
1.0403.
For what?
03.
0.07 or 0.3? Okay, so when they do it this way, the true percent increase every year would be what? This, in this case, is 4.03%. That's called the APY. That's your actual yield. Your actual yield is a little bit higher because of the way that they started out calculating the monthly interest by dividing by 12. So the APR is the number that's usually given, but with compounding, the yield is a little bit better. So here's some different scenarios. In each case, I want you to find, along the way, I want you to find the value. The value of R is the decimal version of the APR, okay? The value of R is the decimal version of the APR. So here's just, is there a blank sheet? Yeah, next page, there's some blank area. So find the annual growth factor for each of these scenarios. APR of 12%, compounding 4 times a year. APR of 4.75%, compounded 365 times a year. APR of 8.9, compounded etc. And then finally, can we get a general form for this 1 year growth factor based on the given rate and the number of times compounding per year? That's our goal. All right, so just we'll do these 3 to see if we can develop the pattern. Okay?
R is what again?
R is the decimal version of the APR. APR is the percent. R is the same number as a decimal. R is the same number as the APR, but as a decimal rather than a percent. So we start with 0.12 divided by 4, right? And what does that number represent? Not monthly. It's not monthly. It is a growth factor, or it's not, no, sorry. It's not a growth factor. Quarterly increase. How do we get the quarterly growth factor? Quarterly growth factor. Add 1. Right? And now how about the corresponding annual growth factor? Take the quarterly and?
No, raise it to the 4.
How many quarters in a year? We're going to multiply that by that 4 times. Okay? Value of R for 4.75%. Zero, 475, right? What are we going to divide by? So what is this number represent? Daily increase. Daily increase. So daily growth factor. 1 plus that is the daily growth factor.
To the 365.
And to get the annual growth factor, then we're going to raise that to the 365. This is all the stuff we've done before. The only new thing is this thing the bank does. They take that annual, the APR, and they divide it into how many times per year, which we said before, we said no good. But now the bank, that's what the bank does. Okay? APR, R value, 0.089. Monthly increase, monthly growth factor. That's the monthly growth factor, so what's the annual growth factor? Okay, so now, we have any value of R. What's n compoundings in a year? How much does it increase every compounding period? If we have R and n, how much does it increase every compounding period? R over n. What's the growth factor for that one compounding period? 1 plus R over n.
To the n.
What's the annual growth factor? To the n. Okay, so this number inside the parentheses is the one compounding period. What? What kind of number is it? This is the one compounding period growth factor. What's the whole thing? I'm going to put a red box around it. So the whole thing that I'm putting a red box around is the annual growth factor. Okay, then what about, one more question? What about the T-year growth factor? So if this is the annual growth factor, so how much we multiply by every 1 year, then what about the T-year growth factor?
And all that to the T?
The whole thing, the annual growth factor, to the T. Right, to the NT. So it's all about growth factors. Compounding period growth factor, annual growth factor, T-year growth factor. See you Friday.